Today's video focuses on motion in one dimension. In physics, we call this kinematics. I'm going to start by introducing the idea of vectors versus scalars, and then I'm going to show the difference between distance and displacement, and the difference between speed and velocity. Finally, I'll talk about acceleration. So let's go. In physics, when we take measurements and we talk about motion, we use two different types of measurements. The first type of measurement is called a scalar. And the second type of measurement is called a vector. First of all, both of them have a magnitude. Okay, they both have magnitude. Scalar and vector, you take a measurement, you need to know the magnitude. It's just how big something is. Okay. The second part of the vector, though, it must have a direction as well. Okay, so the vector has to have magnitude and direction, while the scalar only has magnitude. So one way I told you guys how to remember this is that the V in vector looks a little bit like an arrow. We remember that it tells us which direction. So the first two terms where we see the difference between scalar and vector is distance and displacement. So distance tells us the amount of ground that was covered by an object when it was in motion. Displacement tells us how far out of place an object is. So it sounds pretty similar, but there's a difference between the two. So the vehicle is on the tile, and each tile is half meter. The vehicle is moving forward. Okay, and just move forward 1 meter, and now it's moving backward a half meter. So when we talk about the distance the vehicle traveled, we can say that the vehicle traveled 1.5 meters total. That's the ground it covered. When we talk about the displacement, however, we can say that the vehicle moved 0.5 meter forward, because the displacement only cares about the starting place and the ending place and the difference between the two spots. And the difference between the starting place and the ending place is 0.5 meter forward.
Hey R2, move forward 2 units.
Hey R2, turn right 5 units. Hey R2, move forward 2 units.
Hey R2, do you remember Darth Vader? Hey R2, dance program.
Time equals 9.87 seconds. Distance equals 30 centimeters. Okay, so we know that speed is equal to distance divided by time. Speed is equal to 0.3 meters divided by 9.87 seconds. The green car has the same time and the same distance. So for the green car, we have the speed is equal to distance over time. And it's also equal to 0.0304 meters per second. So they have the same speed, but they have different velocities. And let's see why that is, okay? So the velocity is equal to displacement over time, okay? Displacement here is a positive 0.3 meters. The time is 9.87 seconds. Okay, and that's going to give us the same answer, 0.0304 meters per second. But velocity is a vector, so it includes direction as well. So that's going to give us to the right the velocity of the green car, displacement over time. Displacement here is going to be a negative 0.3 meters. The time is positive, so that's going to be 9.87 seconds. And when we calculate that out, that's going to give us a negative 0.0304 meters per second. So you can see that the velocities are different, but the speeds are the same. First, we're going to show positive acceleration, and positive acceleration is when something is moving in the positive direction and it is speeding up. So starting from zero velocity and increasing velocity. Okay, that's positive acceleration. Now we're going to show negative acceleration, and if something is moving in the positive direction, it's having a negative acceleration if it's already moving with a velocity and it's slowing down. That's negative acceleration. So you guys saw the differences between distance and displacement. We saw the difference between speed and velocity. We saw acceleration, both positive and negative acceleration, and we saw how those ideas are represented with vectors and scalars. I hope you enjoy these demonstrations, and I'll see you next time. The distance versus displacement, we noticed that, what did we notice? We're usually assuming that to the movement to the left is negative. Movement to the right is positive.
Hey R2, dance program. Oh, weird.
Hey R2.
R2's off.
Oh. We are talking about direction.
Oh.
And the difference between and the difference between.
Rude.